This diagram provides a detailed cross-section of a cathode ray tube, or CRT, a vacuum-sealed glass container that meticulously creates an image by directing a high-speed beam of electrons. The entire process initiates at the narrow end of the tube within a component assembly known as the electron gun. It begins with the heater, an electrical filament that glows hot, much like the filament in an incandescent light bulb. This heat is transferred to the cathode, a specially coated metal cap, causing it to release a cloud of negatively charged particles called electrons through a process known as thermionic emission. Immediately following the cathode is the control grid, a small cylinder with an aperture that functions like a precise valve. By varying the electrical voltage applied to this grid, the number of electrons allowed to pass through can be finely controlled, which in turn determines the brightness or intensity of the light spot on the screen. The electrons that pass the grid are then subjected to a powerful electric field generated by a series of anodes, which are held at a very high positive voltage. This strong attraction rapidly accelerates the electrons to a tremendous speed and shapes them into a narrow, focused electron beam, represented by the green dashed line. To ensure the final image is sharp and not blurry, this beam first passes through a focusing coil, an electromagnet that generates a magnetic field. This field acts just like a glass lens, forcing the slightly diverging electrons to converge to a single, fine point on the screen. Next, the focused beam enters the deflection system, which consists of two sets of deflecting coils wrapped around the neck of the tube. These electromagnets generate precise magnetic fields. One pair steers the beam horizontally from left to right, while the other pair steers it vertically from top to bottom. By dynamically controlling the current flowing through these coils, the electron beam can be directed to any point on the screen with incredible speed and accuracy. Finally, the electron beam, now fully accelerated, focused, and aimed, travels the length of the tube and collides with the fluorescent screen at the wide front end. This screen is coated with a layer of phosphor chemicals, which possess the unique property of emitting visible light or fluorescing when struck by high-energy electrons. To form a complete picture, the deflecting coils guide the beam in a rapid scanning pattern, drawing thousands of horizontal lines from top to bottom, while the control grid simultaneously varies the beam's intensity to create the bright and dark areas of the image. This entire process, known as a raster scan, repeats dozens of times per second, so fast that the human eye perceives the single moving dot of light as a stable, complete picture.